Okay, class, this is a limiting reactant problem, or limiting reagent. Either one is the same. I'm assuming that you watched the Goofy Blonde guy on YouTube to explain like what's going on for limiting reactants, so that you know that one of these two reactants is going to end up as, let's try this again, that one of these two reactants is going to end up as a limiting reactant, and the other one's going to be an excess reactant, and we have to figure out which one is which. So in the problem there, he has you compare reactant versus reactant. I'm going to show you something a little bit different that in my opinion makes a little bit more sense to me, so that we can figure out how to do a limiting reactant. You know that a limiting reactant is a reactant that runs out first and stops the reaction then. So no more product can be formed once that limiting reactant stops reacting, or once it runs out. The other reactant then, of course, is the excess reactant, the one that is left over along with the products. So we make the products on the right-hand side, the limiting reactant is completely gone, and the excess reactant is hanging out as one of the as one of the three parts of the solution that's left over. So first thing we're going to do, I'm going to go through this as to how I would solve this specific problem. As it turns out, the next problem on the second screen or the second page for your, for your worksheet follows exactly the same pattern. It follows exactly the same types of calculations. So you can use this as a blueprint for doing the next problem. I did that obviously specifically so that it would be easy for you to follow along. All right, let's get started. The first thing we need to do is we need to work on letter A by balancing the equation. Notice that I have two chlorides on the left-hand side, but only one on the right-hand side, which means I need a 2 in front of the NaCl. If I put the 2 in front of the NaCl, I have two NAs, so I need a 2 in front of the NaNO3. We already have two NO3s there on the right-hand side, and we have one copper per side. So 1, 2, 1, 2 is the balanced equation. This won't work if you don't balance the equation. So balanced equation is essential for this type of calculation. So here's what I'm going to do. You notice that in the video, the guy went from he went from copper chloride to sodium nitrate, and then compared them to see which one runs out first. And then he went from sodium nitrate to copper to see which one, copper chloride, and see which one ran out first. We're not going to do that. What we're going to do is we're going to do two mass-to-mass problems. Yeah, mass-to-mass problems. I'm going to do them on a row, and two of them. I'm going to start with one reactant and form a product, and we're going to see how much of the product we make. Now, in this case here, I have to look at the question to see which product I want to calculate to. So I'm going to start with my reactant of CuCl2. That's the copper 2 chloride right here, and that's 20 grams. So I do 20 grams like this of CuCl2, like that, over 1. Okay, I'm going to multiply by my first step for mass-to-mass problems. Oh, by the way, let's take a look. It says 20 grams. Oh, my bad. I'm not reading very well. It's not 20 grams of copper chloride. It is 15 grams of copper chloride, okay? And we're going to find out how much sodium chloride that we form here. So I'm going to go from copper chloride to sodium chloride and see how much that is. So my first step here is to do the 1 mole of copper chloride, like this, equals some number of grams of copper chloride, like that. What is that number of grams of copper chloride? So over here I do CuCl, I do a 1 and a 2, okay, times 63.5 times 35.5, okay? Let me just check copper because I don't know if I remember that. 63.5, hey, I got it just right. So that's a 0, that's a 9, and that's a 9, so 99.0. Okay, excellent. So that's 99.0 grams of that. My next step then is where I change from copper chloride to sodium chloride. So that means 1 mole of copper chloride on top, so I need 1 mole 1 mole because the balance equation has a 1 in front. So 1 mole of copper chloride, like that on the bottom, so that that cancels with that. I got grams of copper chloride canceling with grams of copper chloride. Good. And then that means I have, now take a look at that, I have 2 moles of sodium chloride. Okay? So now my last step is to come back and make, it says how much sodium chloride. We're going to assume that means mass, which means 1 mole of sodium chloride on the bottom, some number of grams of sodium chloride then on top. Sodium chloride 1 and 1 times 35.5 equals 35.5. This is times 23.0 equals, that's a point, there we go, equals 23.0, which is 50, oops, there we go, 58.5. So 58.5, like that, and then equals. So this is my first mass-to-mass problem. So I go 15 divided by 99 times 2 times 58.5 equals. What I get on the end here is 17.7 grams of sodium chloride. Okay, so that's the mass of sodium chloride. I get rid of this. I do the same thing, except this time, this is going to be easier because I'm going to go sodium nitrate, which is 20 grams of sodium nitrate, like that, over 1. I'm going to do the same thing. It's 1 mole of sodium nitrate. Okay, now I've already done the end to this already. I'll show you what I mean by that. So the only thing I need to do, the extra thing I need to do, is just sodium and nitrogen and oxygen, 113 times 23 times 14 times 16 is 48 plus 23, 48 plus 23 plus 14 equals 85. So 85 grams of sodium nitrate. This is all the same work that we've been doing here. As far as atomic mass units or using molar mass is what I did over there with NaNO3. Now I'm going to convert from grams of NaNO3, or I'm sorry, moles of NaNO3 to moles of NaCl. So here's what that looks like. We're going to find this to be just a little bit redundant because here I have 2 moles of NaNO3 because of the 2 that's in front of my equation. Notice there's still a 2 in front of my NaCl, so that's 2 over 2, so we can effectively ignore those 2. And now my last step is exactly the same, 58.5 grams of NaCl over 1 mole of NaCl, like that. So, as I do this calculation, I do 20 divided by 85 times 2 divided by 2 times 58.5. So here I got 13.8 grams of sodium chloride. Whichever one produces the lower amount is the limiting reactant. That means that the 20 grams of sodium nitrate runs out first. That means that this right here is the limiting reactant. So when you ask, it says how much sodium chloride can be formed, the answer is always by the limiting reactant, which means 13.8 grams of sodium chloride can be formed. What is the limiting reactant? In question number 2, I think they mean B. So the limiting reactant is NaNO3. How many grams of copper nitrate can be formed? Let's move down. I'll show you exactly how to do this one. This is another mass-to-mass problem. So we're going to end up doing a bunch of mass-to-mass problems. So I go 20.0 grams like this. Now it actually gets a little bit easier because I'm not doing all of this from scratch again. So that's going to be 1 mole of NaNO3 like this. I always start with the limiting reactant when I'm finding the other product. So limiting reactant is the key, and that is 85 grams of NaNO3. Now I do the same mole to mole conversion I did before, except in this case here, I'm doing copper, oops, let me try that one more time. So that is going to be 1 mole of copper nitrate, like this, because there's a 1 coefficient in front, but I do have 2 moles of NaNO3 because of the coefficient in front of the equation for NaNO3. And then, now here's the new part, I get 1 mole of CuNO3, 2, like that, and now I have to find the number of grams of CuNO3, 2, like that. So I do that over here, Cu, N, and O, and I need a little bit more room. There we go. A little bit more room to get 1. Now the 2 here multiplies by the 1 on the inside, gives me 2, and then that one is 6. Like that. 63.5 equals 63.5. N is 14.0, which equals 28.0. The last one is 16.0, which equals 96.0. And then I simply add those all up, so I'm going to add them all up. I get 63.5 plus 28 plus 96. And that is 187.5 grams. 187.5 grams, like that. So I start at the beginning of 20 grams divided by 85 grams divided by 2 times 187, 187, there we go, 0.5, equals, and now I get over here, to give myself a little bit of room, I get 22.1 grams of CuNO3, 2, like that. 22.1 grams of CuNO3, 2. And that's how much copper nitrate is formed. I know these are long calculations. Sorry about that. So one of the things that we can do to find out, all right, I'm going to cut it. Let's take a look at the excess reactant or excess reagent, how much is left over. So let's do it like this. Let's take my limiting reactant, like this, in grams of sodium nitrate over 1, this, and I'm going to do my same mass to mass conversion again. Oops, thinking too far ahead. And 3, like that, and it's going to be 85 grams of NaNO3. Like that, and now I'm going to find the other reactant, which means 2 moles of NaNO. Whoa, 3. That's awful. NO3, like that, to 1 mole of CuCl2, like that, and now. What is my number? I'm going to move up so I can see what my 1 mole, up. Why is it not moving up? There we go. Up a little bit more, 58.5, no. 99.0, that's the number I needed. So that means that 1 mole of CuCl2 is 99.0 grams of CuCl2. So what I'm going to find out here is how much 20 grams of sodium nitrate reacts with whatever the amount is of copper chloride, and then I'm going to simply subtract the starting amount of copper chloride with the amount that is reacted with the sodium nitrate. So I'll show you what that looks like. So this is 20 divided by 85 divided by 2 times 99 equals. So here's the amount of excess reactant that reacts with the sodium nitrate. That's the number of grams of copper chloride, like this. Now, how much of the copper chloride did we start with? It says in the very beginning, it says that 15 grams of copper chloride we started with, and we're going to just simply subtract the number of grams that actually reacted with copper chloride. So when I subtract the two, I get an excess of 3.35 grams of copper chloride that's left. So this is what we started with. This is the amount that reacted. So this right here is the excess left over. That's it. Okay, thanks for paying attention.